Hello everyone. In the previous video we covered methods in Python and how they work with classes. And in this video we are going to be covering special methods. So let's take a look at our triangle class, and we have a variety of methods to help with the usability and functionality of our triangle class. Two that are quite similar is the show and the toString methods. They are used in a way to help print the string or to convert it into a string. And we actually have a series of special methods that can help with converting to strings as well as getting the length of data that's in your class and kind of defining behavior of operators and how they'll interact with the class. So up here is a list of the special operators that you can use when overloading specific operators here in Python. So these are all special methods. You know that they are special because they have two underscores before and after the name. So this one's equals, and this is used for overloading the behavior of the double equals operator. And E is for not equals, and it modifies the behavior of the double equals operator of whatever class you're using. All right, and we have a few more. We have less than or equal to, greater than or equal to, adding, subtracting, dividing, doing floor division, which is like integer division, true division, which is floating point division, how the modulus operator works, how taking the power of the class will work, right? You can define these type of behaviors. But these two are a little bit extra special. It's the special string method, which shows the behavior of how you can convert your class to a string, which is also called when you are printing your class. When you implement this string special method, this will actually take care of our show, which I'll get rid of, and our toString method. Get rid of all of it. Okay, we can have room for that there. Actually, I won't define it there. I'll define it in between. I typically like to define these special methods in between my normal methods and the constructor and destructor. So in this video, we'll cover 5 of them. I will, as an example, I will use the implementation of string. I will use power. I will use add, and then I will use not equals and equals. So first let's start with the string special method. So I'm going to define string. I'm going to say self and other. Other meaning, well, actually just self. I only need self because I'm going to convert the data that's in here to a string. And this will actually look very similar to the toString method that we created. So self.base, and we'll just make it space, separated by spaces. Right, so this is all it'll do. It'll return its base attribute, and then a space, and then a height attribute, then another space, and then its area. So pretty simple. This is what will be called when we print the class. So why don't we look at equals. EQ, these should be underscores. Self and other. So self is what's going to be on the left hand side, and other is what's going to be on the right hand side. So here I'm going to return if self.base is equal to other.base, and right, this keyword came from our use in conditionals. Self.height is equal to other dot height. So we'll return their and if they're both equal, then it'll return a 1. If one or the other or none are equal, then it'll return a 0. Next, we will cover the not equals operator. So we'll have 2 underscores NE, self, and other. This actually will be quite similar to equals, but instead of using testing with double equals and ending it together, we'll say not equals. Okay, so what's left? Well, let's try add and multiply and power. This is what we will try. So I'll have add, self, and other. So what I'm actually going to do here is I'm going to create a temporary class, and I'm going to say temp is equal to triangle. And I'm going to say temp.base is equal to self.base plus other.base. We'll say temp.height is equal to self.height plus other.height. And I'll say temp.area is equal to temp.getArea. And we'll return temp. Right, and this kind of methodology will be kind of similar for the other two operators. So we'll define our multiplication special method, so self and other, and this will actually be very, very close to what we did for add, but instead of adding, we're going to multiply. And actually that should be sufficient. Next we'll have power. Def pow, self, and other. Kind of same methodology. The only idea now is that we exponentiate instead of add. We use the exponentiation operator, and that should get everything done. So we had our string, our special string method, which took care of our toString method, and you might want to keep that there just for compatibility. But this also took care of our show function, because when we print the class, it's going to call this special string method. Right, so here's quite nice because we hit 2 birds with 1 stone. We overloaded the equals operator, and it will return true if self.base and other.base are equal, and self.height is equal to other.height. We have not equals, which will do kind of the opposite. It will return true if both bases from self and other are not equal, and height from both self and other are not equal. With add, multiply, and pal, what we do is that we take our classes attribute wise and we add them attribute by attribute. Add them attribute by attribute, or multiply them attribute by attribute, or exponentiate attribute by attribute. And actually this should be a number. I'm going to say other. This is supposed to be a number, not a class. Okay, so why don't we go about testing this out? So we'll take a similar approach. Why don't we have my try equals triangle. We'll create a basic one, and let's print it right away. Let's test it. We'll say my try. Okay, let's see what happens. Did we generate any errors? No, we didn't. Oh, that's good. Okay, so why don't I try my other functions that they still work. So let's see if scale still works. And we'll convert that to a string, but instead of calling our toString method, what we're going to do is that we're going to cast my try as a string. And we'll print my try string. Now let's see what happens. Okay, so it's able to convert it in the way that we want, the way that we defined. Again, the attribute data for the class is just space separated variables. And in here, we have our space separated attributes, just as we defined here. So our class is doing as we are telling it to. So I'm going to create another triangle, and I'm going to say, I'm going to call the parameterize constructor with 5 and 5. And what I'll do is that I'm going to print if another try is equal to my try. Right, so this statement should return true or false. This is the capability of the outcome. Right, but here I know it should return true because another try has been initialized with the 5 and 5 parameters, so it should be the same as my try when I just scaled it by a factor of 5. So my expected output is that this should be true. I will try now. I will test out my setParams function just to make sure that this still works, and I'll use the same numbers as before in our previous example in the last video, 8 and 6. And you know what? Let's try this again, but we'll test the not equals operator. Right, now because I changed my try, I am expecting that this is true, that another try is no longer equal to my try, that this is true. Okay, so the next thing that I'll do is I'll have my multry, and I'll say this is equal to my try times another try, and we'll just print the result just like that. And now that we multiplied, we just have two operators to check, which is the addition, which I'll call sum try, and we'll add our two classes that we defined before. We'll print it out. And then lastly, we have our power, which I'll call not exp try, but pow try. Should be, we'll do, let's make it a little bit spicy. I'll say sum try to the power of 2. We'll print that out. So let's see if we generate any errors. No, we don't. This is not too bad. This is pretty good. Right, so here when we do the when we create another triangle and we set it equal to the exact same parameters of what my try was scaled to, they are the same. Then when I set the parameters differently, they are no longer the same, and this is true, which is expected. Next, I have my multiplication. I print out the multiplication. And then I have my sum and my exponentiation, which are correct. So the results don't look too bad. Right, and this is because I was able to use the special methods and able to overload these operators. Here is the list. You can always find it online by Googling Python special methods. You should have like a table, or you can find a better description on kind of how these special methods work, their details, that kind of thing. Thank you for watching this video.